Design of microstrip line. It is microstrip substrate. Material. Direct constant 4.4. Switch. Prefer 4. Now set the dimension of the substrate. It is x coordinate. S A is the substrate width at x, and substrate start from 0 of y-axis, and z is 0 axis. X size will SA. Now define SA. SA means width of the substrate. Suppose it is 10 mm. Then X size will be, as it is symmetry, so it will be SA. So minus SA by 2 to length. X size means total length. SA. Now Y size is the substrate thickness. It is defined by, suppose, SB. So SB will be, it is a standard size of suppose it is 0.8 on 3. Z size is the length of the substrate, that is 25 mm. Now ground plane is required. You may select the bottom of substrate and use as a, suppose, substrate 1 is create. You just put it here and change the material. It is copper. By a substrate dimension, so you have to redesign it. same. Y size will be minus of px. Means earlier substrate start from 0 and here it is now minus th. Means 0 to minus th. This th means ground plane thickness, means very thin copper length. So it is normally 0.035, means 35 micrometer. Control C, Control V. Now PA is the, you define the PA, you press L, then it will be length, and it PA means patch width. Normally you have to check the online microstrip line calculator to check the dimension or width of the patch. Suppose I am giving here 3.5 mm. Later I will check what is the correct dimension. Now it is PA and Y size start from SB to TH plus TH, because start from SB and it will it will upward to the substrate. J size will be 725 mm. Patch is created. Now in HFSS, another thing you have to design radiation box. You may design by this way: substrate, Control C V. You just put a radiation box, substrate, how it will be, it is a vacuum. Then you have to modify the box. Suppose it is RA and it will be not 0. Suppose it is minus x dimension, it will start from minus RA, means it will be the larger box than the substrate, means substrate covering. So it will start from minus RB by 2, and Z side must be, it should be 0, Z, and X size RA, then press length L. Okay, it will be, it must be greater than SA, substrate width SA plus 10 mm. RB is SB plus means substrate thickness plus 5 mm. Now it is RA and Y size will be RB. Z side should be same because in HFSS radiation box end from port 1 and start from port 2, means like that the radiation box is designed. You can do one thing, you click red, then go to transparent, give it a transparent. Now modeling is over. Now you have to design port. Here the geometry port should be XY plane because patch is elongated in Z direction, so you have to design port in XY plane. So again you change the, as it is already XY, so no problem. Now you draw rectangle. Here I arbitrarily design rectangle. Now I am just change the dimension. It will be already it is minus suppose it is minus 4, start from minus 3 mm x position, y will be 0 and z will be 0, and z direction x size will be 6 mm and y size it will be taken 4 mm. Now port is defined, so you can do one thing, you have to design another port along the last end position, so you select that one, then it is duplicate along line, so you click duplicate along line and give the z value 25 mm. So at 25 mm distance another port will be designed, so you give enter. Again you have to give 25 mm. Now duplicate arrow line, total number will be 2, so now it is okay. It is now designed for 2. Now assign excitation web port 1. It is, you may use as a new line or none, it cannot be effective anymore. So renormalize all mode 50 ohm, finish. Again web and now rectangular 1, right click, assign excitation web port 2, Next, renormalize. Here renormalize means, suppose you design a transmission line, it may not carry 50 ohm. So when I feed SMA connector the transmission line, that SMA transmission should be SMA connector impedance is 50 ohm. So you have to design the transmission line in such a way it match with 50 ohm line. So initially we give the port just replica of SMA connector. So SMA connector is 50 ohm, so here you consider 50 ohm. So for mismatch, means to reduce the mismatch, we have to design this patch length, patch width such that it give 50 ohm. So then better match may come. So two wave port is designed. Now you see the wave port dimension is larger than the radiation box. So it will, you have to change the radiation box height. So you come HFSS, design properties, SA, I already guess substrate with SB, substrate thickness, TH is the patch thickness, it is patch width, RA is the radiation width, and RV is the radiation height. So I put it here, suppose it is 10 mm. So now it is fine. Now the design is complete. Now you do one thing, select the radiation bands, right click, assign excitation, assign boundary, it is radiation on. Okay, now you can have boundaries, it is radiation, excitation is right, excitation 2. Now you have to setup, add solution setup. So solution frequency is suppose 2 gigahertz, 2.4 gigahertz. Number of pass, now it is 4. Okay, now come add solution setup, frequency shift, start from 0.2 gigahertz, stop 10 gigahertz, step size 0.1. Now solution setup is made. Now it is validation check. Now just analyze all, save the project. Now run is complete. Come result, rectangular plot, S parameter. Now it is db. Now new report. Here more loss is there because impedance is not properly matched.